Hey everyone, I'm starting a new series called Building with Claude API. All right, so it's going to be heavily influenced by the official Building with Claude API course from Anthropic Academy. This series is more for a technical audience who are familiar with Python and programming concepts. So in this video, we're going to talk about how the Claude LLM essentially processes the user input that we give it and gives us the outputs. All right. So essentially, we're going to figure out how, when you say, when you open up the Claude AI and say, how can Claude, and basically give it a prompt. Here we have a prompt. How can Claude help VFX and animation pipelines? Answer in one line. Okay. So this is the prompt that we are giving, right? The user input, and when you press enter, Claude is doing its thing here by means of using this Haiku model, right? And it is returning back an output for us. We're going to try to open up the curtain and see what's happening behind the scenes, all right? For us to get this output based on the input prompt that we have given. In order to understand how the Claude LLMs, be it Haiku or Sonnet or Opus, or basically any LLM, they all work by means of using something called tokens. Okay, so the LLMs don't understand English as how we understand English or language. They work by numbers. Okay, so it's basically a huge probabilistic machine, right? So that's essentially, it's like a supercharged, super powerful probabilistic machinery. All these supercomputers and data centers which are powering these LLMs are essentially predicting the next word. That's all it's doing. All right. To be more accurate, it's predicting the next token based on the tokens that we have given it. Okay. So let's break this a bit further, like to understand tokens. Here's a diagram that can help us understand this. So the first step that happens is, let's say for example, the input is what is quantum computing, right? As a first step, the user input is broken down into these tokens. Okay, now a token is not like an individual word that is there in the sentence that you have given. Token is basically this clumping of characters based on how the LLM provider has decided to clump things up. Okay, for example, let's use this tokenizer tool that OpenAI has exposed. They officially have provided us this tokenizer tool that we could use as a web-based tool. And here, if we give like a user prompt, essentially the same prompt that we had here, right? So how can Claude help VFX and animation pipeline? Answer in one line. So if we give this prompt, you can see the way it is breaking down the tokens. So we can see that most of the time each of the word would be a token, but not quite, right? So here, for example, the word VFX, we have given it as a single word, but FX alone has been considered as a separate token, and V with the space has been considered as a separate token, right? And for example, even some other words, like for example, Superman, it would be taken as two tokens instead of a single token. So it's totally up to the LLM providers to decide how they are going to set this up. And each token has a identifier as well to identify that token. Okay. Now, based on the token IDs, so after it's converted into this token, and each token has a unique identifier. These are the identifiers from OpenAI. Claude obviously will have something different. Now, based on the IDs, right, based on these numbers, the next step would be to create these embeddings, the representation of these tokens in the form of these vector embeddings. So here it is, right? So each of those words, so for example, in this case, the word what is quantum computing. So each token, like so here, what is represented, for example, as this particular vector embedding. So, it's basically list of numbers which represents that token's space in a multi-dimensional graph. So we are all familiar with a 2D graph. Like say for example, this is X and this is Y, right? So to plot a point on this 2D graph, we'll say and this is, let's say for example, is 1, 2, 3 and 4, 1, 2, 3. So if you want to plot 2, 3, say 2 in X and 3 in or y. So this will be that point, right? 2, comma 3. So this is essentially how we plot like a 2D graph, right? Now, here you can see it's a bunch of numbers. It's like, n number of dimensions are used to plot the position of this token ID in, this multidimensional space that the LLMs understand. Okay. So each token lives in this multidimensional space. That's how it makes sense of the world, right? Like based on all the training that has gone into the LLM, based on all the training data and all the processing, all these like, LLM companies like, Anthropic and OpenAI and Gemini do on their respective LLMs. All these tokens live in this multidimensional space. And by means of using these embeddings, these numbers, we can identify them in that space, right? These are essentially that vector points. Now, the next thing after we have these embeddings is we would need to like somehow contextualize each of these words, because the same word, for example, the word quantum could mean different things based on how it is used in a sentence, right? So for example, a quantum could be a discrete individual unit of physical quantity, or it could even mean like extremely small or, occurring at the subatomic level. It could be quantum computing. It could have all these different meanings based on the context. Even, in our example here, how can Claude help with VFX and animation? So animation, you could, it could mean the act of creating these, cartoons. It can also mean being lively. He's like highly animated, right? So it can each of these words can have different meanings based on the context, based on how it is used in a sentence or as an input. So after these embeddings are like the first pass of these embeddings are done, they are contextualized based on the surrounding words. Each of these tokens are contextualized based on the surrounding tokens that has been given, right? So and these numbers are refined accordingly. Then only after this contextualization is the generation of tokens going to happen. Now the generation again is just going to be probability, because these LLMs have been trained on massive amount of data. They understand how a sequence of tokens usually play out, right? So when you say Jack and Jill, right, automatically based on the huge corpus of data that these LLMs have, it will be able to predict. So after Jack and Jill, the next word will be went, and after Jack and Jill went, the next word probably will be up, right? So it's basically guessing, okay? It's just basically giving you this statistical data by means of which it is forming, it's generating the next word, it's just predicting the next token, right? And when you say Jack and Jill went, that word went, it's for the LLM, it's not even a word, it's more of that vector that this numbers which is living in that space, and based on the probability and the connections that it has inferred by the huge training data that it has consumed, it will give you the probabilistic next word of saying Jack and Jill went, then after that up the hill, so that's essentially what these LLMs do, right? So after tokenization, embedding of these the tokenized numbers and contextualization is done, the generation starts. Now the generation is quite interesting. Like for example, like here, so I have given this input as the user input is how can Claude help VFX and animation pipelines. Okay, so this is essentially what we have given as input to like even here in this web interface, right? What happens is, so this user input is basically first of all tokenized, right? And then the embeddings are created, contextualized based on the surrounding tokens, token embeddings, and then the generation happens. Now the generation happens one token at a time. So that's very important to understand here. So because basically, so all these things are converted into numbers, right? It's just numbers. So that's what we're dealing with. We're not dealing with English words or any language words. It's, these numbers. Now, based on those numbers, for representing each of the tokens, right? the next word in this sequence, right? It's not even, so that's so cool, right? It's so profound. Here, it's not even trying to answer your question. It's not answering your question. It's basically predicting the next word in this sequence. So when somebody says, how can Claude help VFX and animation pipelines, right? For the LLM, it's not a question. It's just a series of tokens. And now its task is to predict the next token that should, come here based on its training data. Does it make sense? It's not like a human answering, okay, it's thinking about the question and giving you an answer. Like, it's not giving you a thoughtful answer. It's just basically like based on its data, it's predicting the next word or next number in this series of, vector numbers, right? It's not, and again, it's not a single number. It's obviously it's this list of numbers, right? So this is, so what happens here is, how can Claude help VFX and animation pipeline? So probably, the next word in this series, it could be it could maybe try to find based on its data. It could answer this question by saying, Claude can help. You can start the sentence by saying, how can Claude help VFX and animation pipelines? Claude can help VFX. You can start a sentence like that. You can also say, it can help, or you can say, in the VFX and animation pipelines, Claude, there are all these different ways in which you can answer this question, right? In which you can start the sentence that answers this particular question. So, all it's going to do now, it's going to predict the next word to the best of its ability, right? So here, some, good contenders to the answer for this would be like, maybe Claude can be used, maybe if it wants to go in that direction. Maybe now this particular token will have a percentage, maybe like a percentage of 20%. This would be a good choice for the next token. It can also have, another token, which is it. The sentence could be even started like that. Or we could even have something like in. So these are all the different ways in which you could start the sentence that answers this question, right? So it will give these options. For example, here, even in this diagram, you'll be able to see that when it starts to generate the output, right, based on these, contextualized embeddings, the next word in this, series of words, right? Say, for example, for this question, what is quantum computing ? Maybe the next token, like, here should be quantum. That's how it starts the answer. Or great, I will answer your question, or something like that, or what, these are the, different tokens that could probably be used in this sequence, right, based on probability. Now, another thing to keep in mind is the LLMs won't, be choosing the highest probability token all the time, because if it keeps choosing the highest probability token, it'll just become too predictable. It's, so to introduce a bit of randomness and creativity to the answers that we get, it randomly kind of picks, the next word. And to adjust the parameter, adjust the, the randomness here, there is this attribute called temperature that is used. So we would, discuss about it maybe in a later video. Okay, so with that context, let's go back to this diagram. So here, there are these different words that these tokens, it could probably use. So what it'll do is, it will like pick a token based on the temperature attribute that we have set. It's going to generate this output. Now the sequence of tokens includes this another role. So like the user had given this as the input sequence of tokens. Now the assistant, now we are introducing a new role, which is basically the AI assistant, right? So the assistant has come up with this word. Maybe let's pick Claude. Maybe it wants to answer by saying Claude can be used in the VFX, So maybe that's the word that it has chosen, right? So this becomes the new series of tokens, right? So the only thing that has been generated is just this one token, right? And based on the token, we got the word. And this now is going to be used as the input to do this process all over again. So again, for this series of tokens, this is used as the input. This entire process is repeated for it again. So here again, like, it is tokenized. This entire thing is like, broken down into respect to tokens like, over here, based on the input. And then from the tokens, the embeddings are, generated to find the vector IDs, right? The vectors of each of these values, and then it's contextualized based on the surrounding tokens, and then the next token is generated. So basically, like maybe the next token here would be Claude, could be probably Claude can, right? So maybe that's the next token, and again the whole thing is repeated all over again, and then it'll generate the next word, which is Claude can be, right? So and so on. So it just keeps repeating this until it generates like the answer for us, right? But it's not exactly giving us an answer, it's just predicting the next word. And it does this until it reaches this stop character, which we can specify, and also based on the number of maximum tokens we wanted to generate, based on that it will create these predictions for us, right? So that's essentially what is happening under the hood for us to get these generations, answers for our questions, or like essentially whatever text we give, we are getting the next tokens in the sequence basically by means of this process of tokenizations, and then embeddings, contextualization, and then finally the generation of each word one at a time, right? So like one at a time, Claude, and then this entire thing is given as input for the next word, and so on. And so that's basically what is happening with regards to tokens. Now, with this context, we can understand that tokens are the currency for LLMs, right? So, based on the input tokens we give, right? Like for example here, based on these tokens that we give, right? Processing happens inside in all these huge data centers from these frontier models, and then the output tokens are generated, and there is a cost involved in generating them based on the intelligence of the models, right? Like, here I'm using Haiku, which is the fastest and most, cheapest model from Claude. But there are all the other models, right? Like, Sonnet and Opus, which is like, cost the most. And based on the intelligence, the processing of these tokens cost differ, right? And you can even see the pricing of these tokens over here. Like, this is the latest model pricing. So in order for Claude to process 1 million tokens, when you're using the Haiku model, it costs $1. Okay, so 1 million tokens is like quite a lot, right? But when you actually start using it, you can easily start using a lot of tokens. But 1 million tokens just costs $1 input tokens. And to generate 1 million output tokens, it costs about $5 when you use the Haiku model, right? If you use Sonnet 4.6, it costs about $3 for 1 million tokens. So 3 times more expensive than Haiku, right? And the output token again is 3 times. It's $15 per 1 million tokens. And when it comes to Opus, which is their most intelligent model, it's 5 times more expensive. It's $5 per 1 million tokens, and it's $25 per 1 million output tokens. So we can see that the output tokens cost much more than the input tokens, because it's generating all of this iteratively for each of the words, right? Okay, so now let's make use of the Claude API to do something. Okay, so basically, to get started with Claude, in this tutorial itself, they walk you through how we can set things up, how we can set up the environment for starting to use the API. The first step would be to install the dependencies. So here, the 2 dependencies are like, basically Anthropic is the main dependency. This is more of a library that we're using. You get something from the .env file. You can load the .env file. Okay, so now the thing is, in the .env file, which I have over here, you just create a new file called .env, and on it, create an environment variable called Anthropic API key, and put your key. Okay, so how do you get this key? You can go to the platform console, platform.claude.com, which is basically the Claude console, and there you can actually click on this button to get the API key. You can either click here, or you can also go here to API keys tab, and there you can just click on this button, create key. Okay, so when you click on it, you just need to give a name for your key. It could be like my Shack bot. You can give it whatever name based on your app that you're creating. And once you do that, you'll be presented with the key, and that key is shown only one time. Okay, just copy it and put it somewhere safe, because like for example, even the key that I have here, I can no longer see it from this dashboard, because I have saved it somewhere, so I use it from that, but like you can't see it anymore from this. Make sure you have some balance in your console, because like every time you use the API through the API key, it will cost a bit of money. I've even set up this method that shows us exactly how much each of the calls actually cost. So with that, once you got your API key, just put it over here in this .env file, and then when you load it up using this .env module, it just becomes available in the environment. Okay. Now with that, let's actually import the Anthropic client, which is over here, and we have our we create an instance of the Anthropic client. Okay, and the model that we are going to use is the Haiku model. You can get the name again like of the different models from the documentation. So here, if you go to the API docs models, you'll be able to see the different models that are available. So we have like Haiku, Sonnet, or Opus. You could use any of them. So basically, like you can either use this name or this name. I'm just used this simple name, but actually like when the API returns values, that actually is holding this particular name. So you can use any that you prefer. Just put it over here in the model name. Now actually let's make a call to the LLM. Okay, so this is basically like this command is what helps you to actually start sending messages to the LLM and getting messages back. So it is basically client, which is this instance .messages.create. Okay, these are the three things that you need to specify. Definitely you need to specify the model that you want to use, the maximum number of tokens. So this is something that we discussed earlier as well, and tokens are the currency of these LLMs, right? So you can specify how much about tokens, whether you want 1000 tokens or 100 tokens to be the maximum number of tokens that you want the message that is going to be generated to use. Now whatever max tokens you specify is not going to be like maxed out every time. It's just going to use lesser than the number of tokens that you specify over here. Okay, and then comes the actual messaging, right? And here we need to provide this like a dictionary with the key of role and user. Okay, so this is to tell the LLM that this is what the user, the human, or like the agent or whatever, is prompting the LLM. So here as a user, we are saying this is a content. Okay, so here the content is how can Claude help VFX and animation pipelines, answered in one line. So this is the exact same prompt that we had provided over here, right? And so instead of using the web tool, which under the hood probably is using the same API, we are directly using the API to send that message to the LLM. Okay, so here we have the content. That's it, right? So this message, if we run it now, we're going to get the output as this message object. Okay, so I'm going to run this code and see what output we are going to get out of this. Okay, so we just press Control Enter, and now it, using the API key and all those things, it went to the LLM and it got the result back, and it is now presented this message object. Okay, let's print it out and see what we have received. Cool. So we have received this message object. Okay, and it's got this content object which has a list of text blocks. Okay, so here this is basically where we have the output from the LLM, which is like Claude can accelerate VFX and animation pipelines by automating script generation, asset organization, review, and so on. So it's basically given us the output, basically, which is similar to what we have received here. This basically, this output, we have it, as part of this object. Right, and it also provides us a bunch of other metadata, things like the model that was used here, like Haiku model was used, and the role is here assistant, because it's AI assistant is returning back the result to us. And it also has some useful information like the number of tokens that was actually consumed to do this. Okay, so the input tokens was 24, and for this output, the number of output tokens was 46. And remember, we had specified that it should use a maximum of 100 tokens, and you can see that it used well under the maximum tokens that we asked it to use. Basically, that's it, right? So we have this message object. Most of the time, we'll just need the output, and you can easily get it by saying message dot content, right? So this is object content, and it's list, right? So we want the first element in that list, and we want the text that we have there inside it. So basically this thing, right? So if we press Control Enter now, you can see that we have the same text, the exact text that was returned back from the LLM here, right? So this is pretty cool. Now we can start playing with this to explore what all we can get done by directly using the API instead of using the, the web interface or like the Claude desktop app. We can actually now use the API directly to talk with the LLM. Now I took this a step further and built a method that will help us to understand the exact cost that is involved in making this call, right? Because it's based on tokens, right? So we also have this information over here, and you can do the math of how much input tokens you have given and how much it actually is going to cost. And similarly, like based on the number of output tokens you have received, you can do the calculation to find the cost. So that's essentially what I have done here. You can see that I just got this information from that documentation, and for each of these models I've just created this dictionary where I'm saying, okay, so this for Haiku input is $1 and output is $5, so do the math for me. It is basically a simple helper method. So if you just give it that response object, that message object that you received, it will divide the number of input tokens by million, and again output tokens gets divided by million, and it multiplies it based on that rate, and it returns back the result for us as a string. Okay, so let's run this now and see the cost of this particular call that we just now did. Okay, so let's run this, and here you have it. So the input tokens was 24 and the output tokens was 46 and the total tokens was 70, right? And the cost of doing all of this was just 0.00025 dollars. So that's basically the actual cost of running this call, right? You can even create some sort of a tool where instead of using Claude AI web tool, you can create your own web tool which will continuously keep showing you the cost of your chat, right? In that way you can be cognizant of your usage and do things accordingly, right? But this is pretty cool that Claude API exposes all these useful functionalities for us. So here we have just sent one message and we have received back the output over here, right? But now, as we had already seen in this demonstration, in this explanation, that yes, based on the user input, the assistant's output is generated one by one and presented back to us. So it's over here. But the thing is, now if you want to ask a follow-up question, here it's saying it can help with script generation, asset organization, and review frame sequences and so on. So maybe if you want to follow it up by saying, okay, can you explain more on how I could use it for asset organization, right? You want to have a follow-up conversation, right? Just like how you would do it the web tool. Now, in order for us to do that, right, if you just go and take this call again, let's create another code block, and if you just say, tell me more about how I can use this for asset organization. Okay, so I've just given this as my follow-up message. I'm just asking it to tell more about how I can use it for asset organization, right? Now, if I run this, so you can see that it is still trying to give us an output, right? It's saying asset organization with I would happy help, but I noticed you haven't mentioned which specific tool or system you're referring to, right? Could you clarify what you're asking for, right? It doesn't really have that context because all the context you have provided here is just this, okay? It doesn't have memory. It is a stateless machine, right? It doesn't know what you asked it to do in a previous call. So it is up to us to specify the context, right? So that's essentially why we have these messages as a list. The way you create these follow-up conversations, essentially having this context window, is by means of maintaining the messages ourselves and providing it back as a context window for the chats that we do. For example, this is how you would do it. So what I'm going to do is I'm going to run this call again. So, this is the first message that we sent, right? How can Claude help with VFX and animation pipelines? Now that's going to give us this output, which is over here, right? So Claude can streamline VFX and pipelines and all those things. Here it's saying it can help by automating script generation. So we'll just ask it to give us more information on that, right? To do that, what we should do now is it's up to us to give us the first message, all of this again. So basically, remember the whiteboard session. So, whatever we had before, all that context we have to feed back in to Claude for us to have a conversation. Okay, so here we first need to provide what we had initially asked, the first message that we had sent to the LLM. And then, we have to create another dictionary, right? And now the role would be assistant, right? And assistant, and here whatever output it had given, right, like that has to be sent back. Okay, so we have to send it back here, right? So now this is basically like that context that we are building, right? The context window, if you will, right? So here, like, initially the user had sent this, and based on that, right, like the assistant, this return back this information for us. Now again, the user is asking a follow-up question. So here, let's ask a follow-up question. So we'll just say, can you tell me more about automating script generation? All right, so we just have given this follow-up message, right? So with all of this context, it's going to generate a actual response that is useful for us, okay? So let's run this now. It returned back the message. So let's run the message text and see what it responded. So here you can see it is now giving us useful messages like Claude can generate Python scripts for tasks like batch processing, file organization, asset management, shader creation, and pipeline automation, reducing manual coding time, right? So it's basically now giving us a intelligent answer, right? Because we have provided all this context. Now, the thing is, if you now calculate the cost of this message, right, you can see that it's starting to add up, right? Like, because the context window, as it becomes bigger, right? Imagine if you're feeding more context, like maybe you're like feeding some PDF as more as additional context, and additional resources like web scraping, data, and all of this. The number of tokens that you consume can quickly add up. So from the initial number of tokens that we had consumed, now it already has become like, the input token is 94 and the output is 37, and now it's like, totally 131 tokens are consumed, and this is the cost for that. Basically, that's how we can make use of the Claude API to generate responses for us based on the prompts that we provide, right? So it's quite fascinating, and in the next series of videos, we will dive deeper into all the different things that we could do with the Claude API and interesting things that we could build with it. Follow along if you're exploring AI for your VFX and animation pipelines.